Hi, and welcome back to another episode of the Aerial Outsider Podcast. I'm your host, Kyle, and a small business owner here in the Omaha, Nebraska area. I wanted to talk about thermal imaging today as it is one of my core 4 services that I do as a drone business here in Omaha. Whether you're a homeowner trying to figure out why your energy bill's through the roof, or a business owner managing multiple facilities, thermal imaging can give you answers fast, accurately, and visually. What happens when you pair thermal cameras with drones? You're not just taking pictures, you're capturing heat in a picture, and you're turning invisible problems into visual solutions. This episode is brought to you by Netzel Air Drone Services, LLC, an Omaha-based drone service company that focuses on thermal imaging, real estate, small events, construction monitoring, and real estate. So, what is thermal imaging? Thermal imaging is the process of capturing infrared radiation, aka heat, and converting it into a visual image. Every object emits heat, and thermal cameras detect those variations. When you're looking at a thermal camera screen, you're going to have a choice of different color variations between what different heat shows up differently in those color variations. So when looking at that screen, sometimes a white, hot, black, cold looks better for detecting different things on a thermal camera rather than black, cold, white, or black, hot, white, cold. So switching those between those color variations can help you determine what it is that you're looking at, and also determine what it might be. Each color palette can help you differently in every situation. Me, personally, I like to use the color palette called Iron Bow. And so when you're looking at a thermal screen through the eyes of a thermal drone, Iron Bow, the hotter the object is, it's going to radiate a more white-yellow look, with the yellows and bright reds being hot, and then anything cooler is going to emit blue, purple, and a deep, deep, deep purple for very cold. So here's the kicker. Did you know that a thermal camera can look into any window and it can see things that radiate heat that is behind it? Yes. This cracks the myth that thermal cameras see into windows. Any glass window, any type of window that you can think of is like a mirror to a thermal camera. So when you're using a thermal camera for a roof, think of it this way. You can detect problems that may or may not have been seen when you're up on a roof, especially a handheld thermal camera. That can only see what you're pointing it at in the field of vision that it has. Whereas if you put a thermal camera on a drone, you can see a lot more. So why does this matter for homeowners? For one, it can detect insulation issues. Where is the heat escaping or entering during the winter or summer? And if it's during the summer, where is the cold air escaping? When I've done thermal imaging on houses, as far as when I'm just doing it for content, it depends on the angle, but you can see the studs and then the insulation in between each individual stud. This can help you determine, okay, is the house insulated correctly? Now, I can tell you right now, for the house that I am in right now with my family, our master closet is extremely cold during the winter time. I've looked at it during multiple times with my drone when I first got it, and I can see a clear change between where the wall is to the master bedroom and the master closet. The insulation just kind of abruptly ends, and then the master closet just glows with the white yellow hue to it on the thermal camera. So that tells me, as a certified thermographer, that the closet is where there is little to no insulation on the walls, and that could potentially be causing your heat bill to skyrocket. As far as roofs go, you can tell if there's any roof leaks on the roof by flying the drone to look at the roof at the angle where it looks flat, and you can tell if there's any leaks. How you do this is you have to look at it when it's completely dry and within a half hour of sunset or within a half hour of sunrise. The way you do it is that the roof will look cool after the sun goes down, but any moisture on that roof will take a lot longer to cool off after the sun goes down, or it will take a lot longer to heat up after the sun comes up. And so that tells you that if you have cold spots when the sun comes up, that there may be some leaks on the roof. And it's vice versa when the sun goes down. You can also tell us if there's any HVAC inefficiencies, like ducts leaking air or systems overworking. You can tell that because the unit might be glowing a little bit hotter than normal, because most drones that have a thermal camera have the ability to do a spot check at anywhere on the screen. So all I would do is have to tap my finger on the screen and be able to see what the temperature relatively is, because the fun fact about drones with a thermal camera is that handheld thermal cameras take into account ambient air temperature, whereas drones with a thermal camera do not. So that is one rule ability that handheld thermal cameras have over the drones, is that you have to take into account the ambient air temperature as to why something may look hotter. So if it's 90 degrees out and you tap your screen on that HVAC unit and it says it's 110, well, there may be some humidity in the air. That could be explaining why it's 20 degrees hotter. But then again, if you tap your finger on the screen, that could also mean that there's some sort of inefficiency in that unit. You can spot electrical hotspots. Have you ever wondered why a wire is glowing hotter than all the rest? That could mean that there's a kink in the wire. That could also mean that maybe something is wrong electrical wise, which would mean you would have to fix that immediately, unless you really wanted your house to burn down. But I would think anything beyond that you would have to fix immediately. But that's kind of the 4 bullet points as to why it's important to homeowners, especially with roofs and electrical hotspots, and extremely important for electrical hotspots, because I will tell you this, is you would not want your house to burn down. Roofs, especially here in Nebraska, where we get rain and hail, you would want to get that fixed looked at pretty quickly, because a lot of times during the summer it will get really hot for a week and a half, and then we would get rain. So that's another thing why it's important for homeowners, why it matters for business owners, especially if you're managing a lot of building sites. Drones with thermal cameras work really well with flat roofs. So then, like I've mentioned up above or earlier, with homeowners, the roof works the same way. Especially with liquid on the roof or potential leak areas, you would just do the same thing. Only the camera is at a nadir position. Nadir is 90 degrees straight down. And you have to be at the right angle to see all this, because you could be at an off angle and the colors may be off, because every object radiates heat differently, especially depending on where the thermal camera is. So if you're slightly off from a nadir position, you may see the roof have a slightly variated heat radiation versus if you were at a nadir degree position with your camera. So that is one thing you have to keep in mind when doing roof integrity inspections with a thermal drone. It can also detect equipment overheating before failure, basically like the HVAC unit or whatever else is on the roof. The only thing here that matters differently than, say, for an HVAC unit, you do this during the brightest and hottest part of the day, is solar panels. So if you're a business owner and you have solar panels powering part of your building for your business, you would take the thermal drone and you would go out during the hottest part of the day, and when the sun is its greatest on the solar panel, fly above, flip it to your thermal camera, and you would be able to detect where the solar panel is not running as efficiently as it should. What you look for when you are doing this is that you look for the cold spots. These cold spots are going to tell you that this part of the solar panel is not working efficiently. If you look at the cold spots, maybe you only replace, that spot of the solar panel. I'm not an expert in solar panels, but hopefully there's a way to replace just that part so that you don't have to replace the whole solar panel. And especially if you have a dual camera where the thermal camera is built into the gimbal, you can flip back and forth between the regular camera and the thermal camera. And then this in turn helps you determine whether or not it is, say, maybe damaged, and maybe that's why there is a cold spot there. This is really valuable because if your building is partly off grid, then you can actually tell, okay, this is why I'm not getting as much power as I used to, especially maybe if after there's a hailstorm, maybe one of the hail, hit the solar panel in such a way that maybe it shattered part of it. And that is potentially a reason or a cause as to why that happened. And if it did spider web, or if it did hit the solar panel hard enough, you might be able to see that with the regular camera anyways. And then it would just depend on how you are able to fix that, as far as if you're replacing the whole quarter of the solar panel or if you're able to fix just that part. But like I said, I'm not an expert, so you would have to consult with a solar panel expert on that. So what's different between roofs and solar panels? So as a drone service company, when I'm quoting services for, say, thermal imaging, if it's a roof roof inspection with thermal imaging, you're going to do that at night. The best time to do roofs is at night. And like I said, especially between that half hour after sunset and half hour before sunrise, because you want to do that when you don't have the sun beating down on the roof, and that sun is going to mess with the results. So because the moisture is gonna take so long to cool down after sunset, you're gonna want to do that kind of in the early part of the night, because then that's when the roof is really gonna cool down, but that water is still gonna be hotter. Obviously, if you were to go touch the water, you wouldn't notice a difference, but the thermal camera does. So when I'm doing a roof inspection, I'll go do the mission. I'll come back, plug it into my thermal program, and then when I get the results, I'll write a small paragraph explaining the spots that I see that are wrong potentially with the roof. And then they can in turn use that, give that to the roofing company. They can go check out those spots. You can see structural inconsistencies. Like I said, with the thermal imaging, being able to kind of see where the insulation might be. You can see the studs, you can see the insulation as the colder or cooler spots. But also another important thing to remember when doing this is that you want to try and do these inspections when there's a 10-degree difference between the inside of the building and the outside air temperature. So say it's 40 degrees outside, you want to do this with the building being at, say, maybe a 60-degree temperature. Or if it's really hot outside, you want to make sure the building is more than 10 degrees off than the outside. That way you can actually see as accurately as possible what is coming off the building as far as radiation, heat radiation. And so that kind of leads me into solar panels. Between what's different is that solar panels you want to do during the day. So if the solar panels are at, say a slanted roof, you want to make sure you're not hovering directly over the solar panels and over the roof at a close angle. You want to position the drone so that when you do rotate the camera down, you're not going to be at that 90 degrees. You're going to be at the degree of what you're looking at the solar panel. So if it's like, say, 60 degrees, you're going to point down so it looks like it's at a nadir position, but in reality, you're offset from the roof. You're just angling the camera down to look at it like if you were straight down. But even solar panels that you're looking for the cold spots, but I think sometimes you can see some hot spots too of where maybe they're shorting out. That could be an issue with solar panels as well. Uneven heat distribution could also mean that there's something wrong, and then those could be potential fire risks. You want to mitigate that as soon as possible, because since solar panels are on roofs, that could spread to the building really quickly. So you want to mitigate that as much as possible. Roof scans are more about energy loss and water damage, whereas solar panels are about performance and safety. Both are valuable and both require different analysis, and that's where the science comes in. So, like I said before, I'm just scratching the surface with thermal imaging. There is a whole ton of different objects that radiate differently between water, electrical, and so much more. So that's why I say I'm a level 1 thermographer, have been since 22, but when you're doing a thermal job, you're going to come across some stuff that maybe you need to look up. So, even the thermal imaging itself is a science all within, it's balled up all into one. And so using technology and a science like that is just so cool, but it's always a learning process, a learning curve as well. So thermal imaging isn't just point and shoot, it's science. You have to understand the emissivity of an object is how different materials emit heat. So that is very true. So a roof is going to emit heat a lot differently than, say, the siding on a house or a plastic kid slide with a puddle of water in it. That's going to emit heat differently, especially let's go down memory lane and think about the slides, the metal slides in those playgrounds that you were always afraid to go on when it was a sunny day, because if you did, your legs would be burning like burnt toast coming out of a toaster. That's going to emit heat a lot differently than, say, even a swing set, like a piece of wood. You also have environmental factors that are going to be that are going to affect your readings as well. Take, for example, wind. Wind is going to cool down an object, so you have to take into account that, and then also sunlight, and then surface moisture as well. So the thing about roofs is why you have to wait for it to be completely dry is that, say you have a very heavy frost that morning, well, that frost is going to throw off the half hour before sunrise reading, because you don't know if that's just water damage that was there previously, or you don't know if that's the frost or the dew on the roof that is going to affect that reading. So it's not just flying a drone. It's more about interpreting the data, and that's why training and experience matter. It's also why I approach every thermal job with care and precision and commitment to getting it done right. Whether I'm scanning a barn, a roof, or a solar array, I'm not just taking pictures. I'm telling a story about heat and energy and efficiency. So why this matters? So whether you're a homeowner trying to lower your energy bill or a business owner managing a facility, thermal imaging can help. It's fast, it's visual, and it's actionable. And when you pair this technology with the science with drones, you get coverage and safety and insight that ground-based tools just can't match. If you're curious about thermal imaging and you've got a project that needs a scan, reach out. It's one of the most powerful tools in my drone toolkit that I have, and one of the most valuable services that I offer. So I wanted to go over thermal imaging. I know it's a very science-based service that I offer, and I wanted to highlight it because I know that there's a lot of valuable information that can be presented if you do it. The way I like to kind of present it to clients or to potential clients when I'm networking is that I like to say, I'm not just giving you a pretty picture. I'm just going to do the thermal scan. I'll plug in the picture. I'll take a screenshot of the screen that I have for the picture, and I'll put it on a Word document and type up that paragraph of where the problem spots might be. So I try to stand out that way. I don't want to say that it's just a pretty picture and I'm charging more, because it is quite a bit more for a thermal scan, because you're going through all the science, you're paying for the experience, the knowledge at that point, if you will, to be able to do with the thermal image. But I like to try and present it as a little bit pricier than just regular photo and video, because let's face it, anybody can do photo and video. Thermal imaging is more about science, studying, and learning how everything emits heat differently. And that can be really valuable, especially if you're a homeowner or a business owner with multiple buildings. So with that being said, I'd like to do my pitch again. If you would like a thermal thermal scan of your house or your building, of a roof, whatnot, look up Netzel Air Drone Services LLC on Facebook, and I'll read your message and we can talk about what you might have in mind. And this is Kyle Netzel as your host, and thank you again for watching. I do have my podcast page on Facebook, it's Aerial Outsider Podcast on Facebook, and please like and follow. Please comment on this episode as I'll get it up on the Facebook, and we'll be talking again soon. Thank you.